Welcome, friends, to this series of learning containers and Kubernetes. So, in the last lecture, we saw how we can deploy an application on OpenShift cluster. So, as we have come to know that this OpenShift is a managed Kubernetes service provided by Red Hat. So, in this particular lecture, we will actually know what exactly the replica set is and what is meant by the replica set, why we create the replica set in Kubernetes environment. Now, please note this particular lecture is applicable to Kubernetes, not specific to OpenShift cluster, but this replica set concept is there for all the Kubernetes platform across the globe, across the industry. Anywhere you are just running this Kubernetes cluster, the replica set concepts are there and it is same. So it doesn't matter whether it is OpenShift or Google Kubernetes engine or Amazon's Elastic Kubernetes engine, wherever it is, which particular Kubernetes cluster it is, the replica set comes into the picture in the same way. Okay, so let's get started. So replica set in the Kubernetes is a controller that ensures a desired number of identical pods are running at all the times. So when we use the replica sets, it's guarantee a set number of pods replicas are running consistently within a cluster. This maintains applications availability as pods can fail or become inaccessible. So your Kubernetes engine is liable to run that many number of pods to have the stability in the system. Another exciting feature of this replica set is self-healing. Now, if a pod malfunctions, the replica set automatically detects a failure and creates a new pod to replace it. This ensures the desired state of your application is upheld. And obviously, scaling is the main heart of replica set. Replica sets can be used for both horizontal scaling, like adding more pods, and as well as vertical scaling, allocating more resources to existing pods by adjusting the desired number of replicas. Part of a bigger picture, while you won't typically create replica sets directly, they're often used as a building block for the deployments, which provide a declarative approach to managing pod replicas and replica sets. In fact, in this particular tutorial and the demo, we will use these particular features when we run this deployment, when we build the deployment, we will provide the desired number of pods in the replica sets. So let's get started. So in the last lecture, we created our My App, and that particular My App application actually using this MySQL database, which is running from another deployment. Now, if we click this small arrow, which is basically the exposed service URL, we should get the Streamlit application, but we actually not, because the application is actually down. If you closely check this particular My App deployment, you can see there is no pod at all running because it is scaled down to 0, because there was no workload in the system, and so it just scaled it down to 0. But it is not a desired state for a running application in the production, because if the container scales to 0, if there is no pod running into the system, then your application will be behaving like this. Okay, if you scale it up to 1, and if you just refresh this page, you can see your Streamlight application is coming in. So how you can ensure that every time there is at least one pod or maybe two pods or whatever is your desired number of pods running in the system. So this is where our replica set comes into the picture. So let's do one thing. Let's go to our OC CLI and let us do some cleaning. Like we can delete our deployment named my app. We can delete the service named my app. And definitely, I think we will have our root in the system. So we can review once by OC get all. And if we see anything that named as my app, we will be going to delete that as well. So let us review what exactly are there in OC get all. Uh, the name as my app. So if we scroll up, we can see there is a no pod running. Okay, one pod is running, but it is in terminating state. And if we check the service, there is no my app service. If we check the deployment, there is no my app deployment. Now, here actually the replica sets, and here as well, we don't have any my app. And this is the image. I'm fine with the image to be there. Now we are having this root, so we can delete this root actually. All right, so we can check once again. So let me clear the screen, and we can check if everything is just got clear. All right, so we don't have anything named. My app is running as running pod. Service, there is no service, no deployment, replica set, as well as uh, root. Okay, so that's fantastic. So we are having a very clear picture right now. So let's check this topology. We are having just one my app running, and this is basically Gauss. I'm just clearing this one. Okay, now what we will do, we are having one YAML file. So if you closely look this app.yaml file, we can see this is basically a deployment kind of YAML. And if we create this deployment with this app.yaml file, we will have a my app2 named deployment. And here we are specifying the state of the replica should be 2. So that means it is going to be ensured that 2 replicas should be there up and running all the time. And if there is one unhealthy replica comes into the picture, or if somehow one replica dies, then the OpenShift should be liable to create another pod to maintain these number of replicas in the system. We are going to specify the labels. So label is the selector, and we just said that match label is my app2. So this is our my app2 label. And here the spec, we are having one container that should be named as my app2, and this is our image, and container port should be 5000, protocol is TCP, and 5000 target port is also there. So that means because our Learning Light My App application is running inside the container as 5000 port. So we need this 5000 port. And also we are having the same environment variables that we said in the last lecture. So if you somehow miss the last lecture where we actually deployed the My App application in the OpenShift. We are highly recommending you to watch the video to have the clear understanding how to deploy the My App in the Red Hat cluster. And we are providing the link of the video in the description below. So please go through that video once again if you have just missed it. Now, now we are going to create this deployment right now, not through UI, but from this CLI. So we will say OC create, and we are providing this app.yaml file to create the deployment. The deployment is created. We can verify OC get deployment, and we can see this my app 2 with having two pods running, and it is available. So if we can check with minus o wide, we can have some more details like my app 2. It's a selected is app is my app 2, and this is the container and images as well you can see. So let me clear the screen. We can check the pods. So get pods minus o wide. So you can see the my app 2 pods are running, and each of these 2 pods are running on a different EC2 instance, and it is going to be ensured that this my app 2 is actually running all the time. So let's do one tricky things, but before that, let me expose the service. So we can say OC expose deployment my app 2, and we will specify the port is 5000 and target port is 5000 as well. Okay. So if we expose the deployment is exposed. So we can say get SVC minus O wide. We can see one cluster IP has created for my app 2, and it is going to be selected as app as my app 2. And now we can create one root. We can go to this topology and we can see that our my app 2 application is running. Now let's move to this administrative view, and we can go to this networking and we can re-verify the service called my app 2 is up and running from this particular location. So what we will do, we will create one root, and this time we can create the root and we can name the root as my app 2, and we can specify the service as my app 2 what we had just created, and the target port is definitely 5000, and we are going to create it as TLS termination. So root will be secured using several TLS termination used for servicing certificate. All right, so we can click create, and our URL is ready. We can go to this URL and we can see our Streamlit application is actually accessible, and we can click on show items. Our data is saved and we can see the data as well. All right. So till now it's excellent. Now what we will do actually, we will see our pods, and this time we are going to delete one of the pods. Okay, so let me copy this one and we can say delete pod and the pod name. And if we do so, the pod is deleted. But let me go to another terminal and let me verify what are the different pods are running at this moment. All right, so let me watch this. So get pods minus O wide, and we can see Though we have deleted one of the pods, we are having two pods running at the same time, though our pods were deleted. So if you see this particular pod, which is ending with R5618, we can see there is in the terminal 2, there is no such pod is running. But once we deleted this particular pod, the OpenShift cluster actually created another pod in just 70 seconds ago, as it needs to maintain two replicas all the time in the system, no matter what happens of each of them. So if we go ahead and delete both of these pods, so let me say this pod, and we can see both of the pods are deleted. But here you can see, though they are terminating, it automatically spined to new pods at the same time. So this is how the replica set is actually liable to maintain the same number of replicas, whatever is desired in the system, and how we are asking the replica set to maintain that number of replicas in the system. So replica set acts as managers for pods, ensuring their availability and contributing to the overall resilience of your application in the Kubernetes cluster. So thank you for watching this video, friends. So in this particular lecture, we have come to know what exactly the replica set is and what are the benefits of having the replica sets in the Kubernetes cluster, why we should use the replica set in the Kubernetes platform, and why we should maintain the replicas, the number of replicas in the system to have them stability and scalability and resiliency. Thank you for watching this video, friends. Once again, in the upcoming lecture, we will go deep into different things in Kubernetes cluster. So please stay tuned. Thank you.